சார் போட்டு அவர் சார் கையில் கொடுத்துடலாம்.
ஓகே சார், ஸ்டார்ட் பண்ணுங்க சார்.
சார் நான் அப்படியே
பார்ட்டிசிபென்ட் ஸ்கிரீன் ஷேரிங் ஆகுது சார்.
சார் பண்றாரு
சார். நீங்க கொடுத்துறீங்களா சார்? குமார் சார்
ஷேர் ஸ்கிரீன் கொடுத்தலாமா சார்?
நீங்க
கொடுங்க.
சார் நீங்க அக்செப்ட் பண்ணுங்க சார். சார் எனக்கு கிளிக் பண்ண ஹோஸ்ட் டிசேபிள் பார்ட்டிசிபென்ட் ஸ்கிரீன் ஷேரிங்
இப்ப பண்ணிட்டேன் சார். கொடுத்துட்டேனே அக்செப்ட்.
ஓகே சார், இப்போ வந்துருச்சு சார். கரெக்ட்டா இருக்கா பாருங்க.
வருது சார். F5 பிரஸ் பண்ணிக்கோங்க.
சார் ஸ்டார்ட் பண்ணிக்கலாமா?
ஸ்டார்ட் பண்ணிடுங்க சார்.
So good afternoon to all. Is it okay? Audible is okay?
Yes sir.
Okay. So first of all, I would like to thank Dr. Y.B. Kannan sir, Assistant Professor in Department of Physics, Arumugam Pillai, Seethai, Ammal College, Madurai. Sir, is it okay?
Senior sir.
Sir, is it audible?
Audible, sir.
Okay. So I am really glad to be here for giving a webinar in the title of Importance of Nanostructured Thin Film Cathode Materials for Lithium-ion Batteries. So nowadays, storing the energy is really challenging, and also it is very important to different application. So that's why I have selected this topic for the seminar. So I would like, I am, my outline of the talk would be like this. I will tell you the history of the battery and types of battery. And in that battery, I will tell you the advantage of lithium-ion batteries. After that, I will cover with the basic working principle of lithium-ion batteries. In that, I will tell you the importance of thin film cathode materials in batteries. So in this topic, I will tell you in detail of the preparation of thin film and how to optimize the thin film for the suitable batteries. Then after, I will tell you the different synthesis of the cathode material and related to the characterization of the different material. And finally, I will tell you the applications. So these are all.
மேடம் ஒரு நிமிஷம் வந்துடுறேன் மேடம். கட் ஆகிட்டு வருது. இந்த வந்து சார் கண்ணன் சார். சார் கண்ணன் சார். சார் வர்றாரா? மைக் ஆஃப் பண்ணிருக்கு சார், கொஞ்சம் ஆன் பண்ணுங்க உங்க மைக். சாரை காணோம். சார் லீவ் ஆயிட்டாரா?
இல்லையே, கட் ஆயிட்டனால ஒருத்தர் வர சொல்லுவா.
வர சொல்லுங்களேன்.
சார் திரும்ப வெளியில ஒருத்தர் வெளியில வந்துட்டு நான் சொல்றேன் எந்த ஸ்லைடு தேவி கோன் ஸ்லைடு காட்டுறீங்க தேவி கோன் ஸ்லைடு காட்டுறீங்க டைப்ஸ் the types of இதுல கட்டாச்சா சார் types of media சீனியர் சார் அவர் உள்ள வந்துட்டாரு அவர் கொடுத்து
என்டர் பண்ணிட்டேன் சார் சார் வந்துட்டார் சார் அப்படியே லைவ்ல இருக்கு பேசுங்க சார்
சார் லைவ்ல இருக்கு சார் பேசுங்க சிவா சார்
சார் பேசுங்க சார்
சிவா சார் நீங்க பேசுறது கேட்கல அன்மியூட் பண்ணுங்க
அன்மியூட் பண்ணிக்கங்க சார்
சார் இப்போ கேக்குதா
ஓகே சார் ஓகே அப்படியே பண்ணுங்க
கண்டினியூ பண்ணலாம்
சார் திரும்ப ஷேர் ஸ்கிரீன் கொடுக்கணுமா
ஆமா சார் நீங்க தான் தெரியுங்க பிபிடி வரல
சார் ஹோஸ்ட் சார் அவங்க அக்செப்ட் பண்ணும் சார்
இந்த பண்றாங்க
சார் அவருக்கு கொடுக்கல சார் ஒன்றும் ஓகே சார் அவருக்கு ஒரு கால் பண்ணுங்க சார்
இல்ல அவரை நீங்க அலோவ் பண்ணல அவருக்கு ஷேர் ஸ்கிரீன் வர மாதிரி
கொடுங்க
சார் ஓகே சார்
ஓகே சார்
சார் செகண்ட் ஸ்லைட்ல இந்த
டைப்ஸ் ஆஃப் பெர்த் மெத்தட்
okay so நான் இதுல இருந்து அப்படியே ஸ்டார்ட் பண்ணேன் okay so let me start once again okay sir so I will tell you the working principle of lithium and batteries, and after that I will cover with the importance of lithium ion batteries like thin film form of cathode materials which is used for different application, and also I will tell you the different types of synthesis method. From that method, how one can prepare the cathode materials, and I will tell you the important characteristics of the cathode materials, and finally I will tell you the applications. Sir, is it audible, sir? Kanan sir?
Yes, sir, audible.
Okay, so let me start with this slide. So here you can see the growing population. So every decade the number of population is becoming increasing, not only in India, throughout the world. So based on that, most of them are moving to the city side. So urbanization has become more nowadays. So we need a highly, need of electricity to all of them. So it's a really demand of storing the energy. So that is the reason not only the physicist, like chemists also, they are working in lithium and batteries, so to fulfill the needs. So this is the idea to give the good product of energy storage with the new concept like energy efficiency, and it should be in the low emission, and also it should be affordable to everyone, and also it should be suitable for day-to-day life. So these are all the important parameters for producing the good product of lithium-ion batteries. So in this idea, so I will tell you overall flow chart of the world electricity generation by fuel. So right now we are actually getting the 15.2% of source from nuclear sources, and 16% from hydro sources. So we are getting the electricity from hydro sources for 16%, and also 19.7% from gas, and 6.6% from oil, and the remaining from coal. So these are all the different type of sources we are getting the electricity, but it is not enough to fulfill all the needs. So it's really need of energy storage in future generation, and also you can see the demand will increase up to 50% by 2040. So that is the reason most of the scientists they are actually working in this field. So in this slide, you can see the overall idea of how we are getting the electricity from different sources. So we are actually, I already mentioned that one, we are getting the power from power plant, and from hydropower plant, we are getting the electricity. And from solar farm also, we are getting the energy. And of course, from wind farm, so from a wind source also, we are getting the electricity. So these sources are not enough for our needs. So really we need a energy storage device or energy storage on one team for getting the electricity. So this is the idea of producing the energy storage for different things. So I will tell you the basic history of the battery. All of you know that we already studied in the school level. In the 18th century, Volta actually he prepared the first battery with the silver and zinc electrode. And in later on, 1836, Daniel he replaced silver with copper. So that time the voltage got some improved value. After that, 1857, Planté he actually discovered the rechargeable lead acid cell battery for different application. So these are all the history of the battery. Then in 1898, the commercial flashlight discovered, and after that, in 1970s also, lithium and sealed lead acid were used. So the big miracle happened in 1990, or I can say like 1991. Sony from Japan company, they actually discovered the lithium-ion battery, which is called rechargeable battery. So still now we are actually using that lithium-ion batteries for all the electronic gadgets. So this is a difference between the rechargeable battery and the primary battery. I will tell you the difference also in the coming slide. So this is the history of the battery. So in 1991, they actually discovered the lithium-ion batteries. So still now we are using that one. This slide, you can see the different shapes or different size of the batteries for the suitable application. So this is called 9-volt battery. So this is a 6-volt dry cell. So if you open the battery, inside the three elements are like this. So one is cathode and another one is anode, and in between the electrolyte is acting as a major role. So I will explain that also. So before that, I will tell you the basic characteristic of the battery. So all of you know that we are day-to-day life, we are using the different kind of batteries for different application, like AAA battery, which is small one, where we are using in that remote control and other devices, and AA battery, and C and D battery are big size battery for different application. So in this battery, the important parameter is energy density. So energy density should be more in that battery. So that is very important. So if the energy density is more, means the performance of the battery will be high. So that is important things. So every scientist actually, they are actually focusing on how to improve the energy density of the particular battery. So that is a really challenging one for the scientist. And also another characteristic is the capacity. So the capacity of the battery should be high. So then only the duration. And also number of recharge cycling is also important. So these are all the important parameters we have to optimize. So these are all the standard modern batteries. We already studied in that basic level, like zinc carbon. It is one of the best example for AA battery and C batteries. And alkaline battery, we can use it for common Duracell and energy batteries. And lead acid batteries, we can use it. And this slide shows you the difference between primary battery and rechargeable battery. So here we have to really understand the basic concept. So primary battery is nothing but a disposable battery. So we can use that battery. After usage, we have to throw it out. So we cannot use it again. Whereas in the secondary battery, it is called a rechargeable battery. We can use the battery. After discharge, we can charge it and we can again use it for a particular time. So this is the main difference between the primary battery and secondary battery. So after 1990, still now we are actually using the secondary battery, where in the mobile, in the camera, in the laptop, in most of the gadgets, we are actually using the secondary battery. So hereafter, I will tell you only the importance of secondary battery. So lithium ion batteries is coming under the secondary battery. Okay. So here you can see the few examples of the disposable battery, and also in disposable battery for the different applications. We already studied. This is the cross section of the cylindrical battery. So we already studied in the basic level. So red one, it indicates the silver plate, and the blue one, it indicates the zinc plate. So these are all the two electrodes. So two electrodes. So in between, you can see the white one. This is a blotting paper. So previous days, they used this blotting paper for the electrolyte. So they fill the electrolyte, and it can act as electrolyte. The purpose of electrolyte is it can allow the ions from one electrode to another electrode. It won't allow the electrons. So that is the main purpose. I will explain that one also in the working principle points. So these are all the secondary batteries. The examples are nickel cadmium, nickel metal hydride, alkaline, lithium ions, and lithium ion polymers, and lead acid. So hereafter, I will concentrate only the lithium ion batteries and the importance of lithium ion, and how we can prepare the lithium ion batteries, like in cathode materials, and where we can use it. Okay. So this is the basic concept, and I will tell you the few importance of lithium ion batteries. It gives a 40% more capacity compared to nickel cadmium battery. So this is the main advantage of lithium batteries, lithium ion batteries. And it can show the flat discharge compared to nickel cadmium batteries. I will tell you the importance of flat discharge, what is the main advantage. And the self discharge, it is 50% less than nickel cadmium. This is more important because in every battery, the charging should be the faster, and the discharge should be the lower. So this is very, very difficult to optimize. So that here the lithium ion has give the self discharge of 50% less compared to nickel cadmium. So this is one of the important points of the lithium ion batteries. Of course, it should be expensive compared to nickel cadmium. I mean, no, not much. This is only one few drawback of the lithium ion batteries. And this picture shows the lithium ion batteries of the commercial one. So even if you open your mobile, on the back side, you can see this kind of type of lithium ion batteries. Here you can see that 3.7 volt and 3500 milliampere per hour. So this is the voltage range, and this is the energy density of that particular battery. So these kind of batteries are nowadays we are using for the different applications. This is also few advantage of lithium ion batteries. The power density also 160% greater than nickel metal hydride, and 220% greater than nickel cadmium. So this slide shows lithium ion batteries and compared to other batteries. So the specific power, the graph between specific power and specific energy. So in every device, actually the specific energy and the power is also important. I will tell you the difference between energy and power. So lithium ion batteries is also energy device. Okay, on the other hand, the supercapacitor also one of the energy device. Okay, the difference is the supercapacitor has a more power but less energy. But in the case of lithium ion battery, the battery has a higher energy power, I mean energy density compared to power density. But in the case of lithium ion, you can see that, so the energy density is also high as well as the power density is also high. So this is a main advantage of lithium ion batteries. So that is the reason most of the scientists, they are actually concentrating in this lithium ion batteries in order to improve the power density and also energy density. Okay, so here I want to tell you the importance of nano science. Not only in physics, in most of the branches, they are actually working in nanoscience. Why? Because if you go to the nano size of the material, most of the properties are enhanced. For example, in the case of battery, one of the parameters is conductivity and also strength. So two parameters are very important. So once you go to the nano region of the material, the conductivity as well as strength become enhanced. It is coming higher. So that is the reason most of the scientists, they are actually working in the nano region. For example, carbon 60 is the best example for the nano region. Okay. So here, carbon 60 is one of the best example for improving the conductivity value. I will show you one clipping in that you can easily understand how importance of carbon, to why they are adding that carbon in that particular cathode material, and what are the importance. So I will tell you that importance in that future slide. So this is one of the main advantage of nanotechnology in battery side. So here you can see that nanotubes, I already mentioned that carbon material, carbon nanotubes one can prepare to improve the mechanical strength. Okay, so we can use it for the different application. So here I mentioned that one of the few example, like a nano transistor, we can use it in that computer industry. Like even we can go for less than 45 nanometer. So batteries with the nano scale material deliver more power and also with less heat. So that is also an important parameter with reducing the temperature. Okay. So in 2001, from China, they already published this kind of paper related to nano range. For example, tin oxide, they already prepared and they used in that cathode material, and they already proven for the lithium ion batteries. So this is one of the evidence. They already started in 2001 itself. So I hope all of you understand the basic concept of lithium ion batteries and types of batteries, and the importance of nanotechnology and the importance of carbon. Okay, so now I will going into deep, like how it is working, like lithium ion batteries. What is the basic working principle? What is really happening inside the battery in chemistry point of view? Okay, so here you can see two electrodes are there. I already mentioned in batteries, there are three components are important. One is anode and another is cathode and electrolyte. So electrolyte is a liquid electrolyte, and the cathode anode is a solid form. And most of the scientists, they are actually concentrating in the cathode side. So here, this is the clippings, like the basic working principle of lithium-ion batteries. You can see now, I am giving the current. Okay, now you can see what is happening. So the green color, it indicates the lithium ion. It is moving from cathode to anode. So now the voltage is rising from 3 volt to maximum 4.3 voltage. So this is happening in that charging time. Okay. Now I am giving the negative current, which is discharging. At the time of discharging, okay, now all the lithium ions going back to the original position. Okay, now the voltage is coming back to the 3 volt. So this is the basic concept of charging and discharging happening inside the battery. Okay, so this is the main advantage of lithium-ion batteries. This is called the rechargeable batteries. This phenomena won't happen in the primary batteries. So this is the main difference between the primary and secondary batteries. Okay, I hope you can understand the concept. So now most of the scientists, they are actually concentrating to optimize the cathode side, like this side. So how we can improve the performance. So improvement performance means kind of like how to increase the speed of lithium ions. So they're actually doping the material, or they are reducing the grain size. So there are many trial and error are there in order to improve the performance of the cathode side. I will explain you in that future slide of like one example is there. I will explain in that one. So now I hope you can understand the basic principle of lithium-ion batteries, like working principle. Okay, so now I will tell you that there are 3 main types of lithium-ion batteries. One is called the coin cell. Coin cell, I hope you can you may see in most of the devices, like our watches and other applications also, we can you can see that one, coin cell. And pouch cell, second one is the pouch cell. So pouch cell, you can see in that Apple iPhone or Apple iPod. So like in the thin device form, you can see the pouch cell. And the third one is the prismatic cell. In normal mobile and maybe in that laptop backside, you can see that big size of the battery. So based on that, our need, our application, we can divide into 3 parts: coin cell, pouch cell, and prismatic cell. So in the 3 types also, the cathode materials we can prepare. So before going to the next slide, I will show you one clipping, like how we can prepare the cathode materials and how we can use it in that coin cell. Sir Kannan, sir? Sir, can you open that one first movie? I already sent it to you, right?
Kannan, sir.
Sir Kannan, sir, is it possible?
Yeah, wait.
Oh.
அவர் ஏதோ வீடியோ ப்ளே பண்ண சொன்னாரு. அவர் ஏதோ வீடியோ ப்ளே பண்ண சொன்னாரு. அவர் வெயிட் பண்றாரு.
சார் வீடியோ தெரியுதா?
சார் எனக்கு தெரியல.
ஷேர் ஸ்கிரீன் கொடுக்க சொல்லுங்க அவரை. இவரை க்ளோஸ் பண்ணிட்டு அவரை ஷேர் ஸ்கிரீன்.
சார் நீங்க க்ளோஸ் பண்ணிட்டீங்கன்னா அவர் ஷேர் ஸ்கிரீன் கொடுப்பார் சார்.
சார் நம்ம ஸ்டாப் பண்ணுமா சார்?
இல்ல ஸ்டாப் ஸ்கிரீன்.
சார் நான்
ஸ்டாப் பண்ணிடலாம்.
மினிமைஸ் பண்ணுமா சார்?
ஸ்டாப் பண்ணிடுங்க
சார்.
ஆமா ஸ்டாப் பண்ணுங்க, அப்பதான் அது வரும்.
ஓகே
சார் பண்ணுங்க சார். கண்ணன் சார்.
சார் வருதா?
சார் எனக்கு தெரியல.
இன்னும் ஷேர் ஆகலை.
சார் ஸ்கிரீன்
வந்துருச்சு சார்.
வருதா?
இப்போ கொஞ்சம் ப்ளே பண்ணுங்க சார், வரும்.
சார் பெரிய ஸ்கிரீன், பிக் ஸ்கிரீன். So this is a demonstration of how to prepare. Sir, very screen important, sir.
Okay.
Yeah, so this is a clipping of how to prepare or how to assemble the lithium-ion batteries. So step one, so this is a making of slurry. So before going to assemble the battery, so we have to prepare the cathode materials. I already mentioned, right? So there are different methods are available to prepare the cathode materials. So here I have shown one type of method. This is called oxide-based material. So we have to mix this powder into electrolyte. So now you can see that. So now we have to prepare the thin film. So we have to take the aluminum foil or copper foil, so whatever it could be. So it is possible in small scale lab also. So in our lab also we can prepare. This is called a doctor blade method. This is simple method. One can prepare the thin film cathode material. So now we have to drop our prepared sample. So you can see that one. So we have to take our prepared sample. We already mix it with the electrolyte, and it is in that slurry form. So we have to drop it on the aluminum foil. Yeah, so now it is in that so now the coating has been done. After that coating, we have to weigh it. I mean, for measuring the weight of the sample. Then only we can calculate the density. So for drying purpose, we have to put it in that furnace. So once if it is ready, then we have to assemble the cell. So now you can see that after getting that foil, so we have to put it in that vacuum pump. This is called a vacuum pump. Simply we can say that this is called a glove box. So this is the window. So by using this window, we have to put all the assembled cell. Now we have to create the vacuum. After creation of vacuum, we can insert that inert gases. So now we can see they are actually assembling the pouch cell. So this one is a prepared cathode material, and after that they can put the polymer separator. So this is called separator. So the purpose of separator is in order to avoid the short circuit, we can use a separator. Okay. Yeah. So now they are putting that separator. And after that, finally, they can keep the lithium foil. This could be act as an anode. Yeah, finally, they can keep it inside the pouch. So for seeing, it is very easy. For looking wise, it's very easy. But really, for preparing, it's very, very tough because it is happening inside the glow box. Okay, I will show you the full picture of glow box in later slide. So it is very, very tough to prepare the cell. So after assembling that cell, they can put it for the characteristics for testing. This is for testing. So thank you, sir.
Thanks.
Sir, Kanan, sir.
Thank you. And now you start. Now you share your screens. Sir?
Okay, sir. Sir, is it okay?
Yeah.
Okay. So I think now I hope you can understand how we can prepare the cathode materials. After that, how we can assemble the cell in the form of.
The screen was sir.
Yes, sir. Yeah.
What?
Sir, is it okay?
Okay, sir.
So now I am going into details of how one can optimize the cathode materials. Okay, so this is a scenario of the total picture. So right from like we have to optimize the material. So this is really challenging. So here you can see that most of the materials we have to prepare in that monodispersed particle. I can say in simple term monodispersed particles. So it is very, very tough to prepare this kind of monodispersed particles. And there are many methods are available for preparing the cathode materials, like a chemical method, solid state method, and electroless deposition method, and spray coating method. So number of methods are available for preparing the materials. But the point is, so we have to optimize that material. So in order to get that monodispersed particle. Anyway, I will explain the difference in the future slide. So this is very tough to prepare that monodispersed particles. Once you prepare the particles, then we have to make it in the component like this. We have to coat it in that foil. I already shown in that movie. After that, we have to assemble the cell. Finally, we can use it in the application. Yeah. So there are different methods. So I want to show you few selected methods for you. So this is called the redox flow battery method. So from this method, we can go for low voltage, like 1.3 volt, and also energy density it could be 3.02 kilogram volt. And also another method is called sodium sulfur battery. I already mentioned that temperature is also one of the important parameter, because once you prepare the battery, it should work for all kind of temperatures. Okay, so in India, no problem. So the temperature gradient, it could not much. So minimum 20 degree and maximum it could be like 35 or 38. But if you go to Western countries, so the temperature difference could be the large. So maximum 28 to minus 30. So that device should work for the all kind of temperature. So optimizing the temperature different also, it's very, very tough to prepare that material. So this is also one of the challenging for every scientist. So sodium sulfur battery, it could be working for the high temperature also. So this is the importance of the sodium sulfur battery. And another battery, this is also sodium sulfur battery. So here also we can get more voltage. So around 2.06 voltage. Hereafter I will show you the importance of lithium metal phosphate. So before that, I will show you one movie, like how to prepare the coin cell, or otherwise I will tell you this one first. After that, I will show you that movie. Then only you can easily understand. Okay. So here I want to explain you related to cathode materials. In cathode materials, there are three types. One is called oxide materials, and second one is called the phosphate-based materials, and the third one is called the vanadium-based materials. So 10 years before, I already mentioned that in 1990, Sony discovered this secondary battery, lithium-ion batteries. On the time, they used oxide-based material. For example, lithium cobalt oxide, they used that material, cathode material for that device. So in that, the maximum voltage was like a maximum 3 voltage they achieved. So later on, now like 3 years before, in phosphate-based materials, they are actually, it is giving better performance compared to oxide-based materials. Even if you open now, like in most of the a mobile phone, if you open on the back side, you can see that in the battery, they mentioned like lithium iron phosphate with particular energy density. So recently, they are actually preparing the batteries in lithium metal phosphate of cathode materials. So now I will tell you the main difference between oxide-based material and phosphate-based material. Okay, in the left side you can see the graph between voltage and the power. Okay, so the voltage is decreasing drastically and it is coming down. So this is happening in that lithium cobalt oxide. Whereas if you see in the phosphate-based materials, the voltage is coming down, and after particular voltage, it can retain that voltage for a particular duration. So this is the main advantage of phosphate-based material compared to oxide-based materials. So in this region, in this plateau region, you can save the power. So in this plateau region, you can save the lot of time. So which means the discharging time is getting longer. Okay, so that is the reason. And nowadays, our battery we are using for nearly 1 hour to maximum 2 days. 1 day to maximum 2 days. So based on our usage also, because of this advantage, like lithium iron phosphate, the nature of lithium iron phosphate, it gives the plateau region so that the discharging rate become less. So this is a more advantage compared to the oxide-based material. Now you can see the comparison table of phosphate-based material and oxide-based material. Okay, I will tell you a few points, like phosphate-based materials is always safe side compared to oxide-based material. I will tell you one example also. So then you can easily understand. And the cycling life is better compared to oxide-based material. And the temperature range, the phosphate-based material, it can work it from minus 20 degree to maximum 70 degrees Celsius. So this is the most advantage of phosphate-based material. Okay. So here you can see the range of greenhouse gas emission. So compared to other materials, lithium ion gives less than 600 grams per mile of emission, gas emission. Of course, we cannot compare with fuel cells because fuel cell for preparation of fuel cell is expensive. So if you compare with the batteries, so lithium ion gives the less emission compared to other batteries. So this is also one of the important advantage. So this slide shows a clear picture of how we can prepare the cathode materials. After that, after optimization of the cathode materials, how we can prepare the slurry, And after making the slurry, how we can make the electrolyte coating, how we can make it a pouch cell, and finally we can put it in the testing. I already show you one clipping of pouch cell. Okay. Now I will show you how we can prepare the coin cell in the laboratory. Sir, Kannan sir?
Yes, sir.
Sir, can you
Yeah. I will take the second video.
show the
Third.
second view? Okay, sir.
Second or third, sir?
Sir, second.
Okay, sir. Sir, could you please stop your screen sharing?
Yeah. So here you can see the glow box. Anyway, he is explaining the basic concept. Sir, sound is not coming, right? Yeah. So what you are seeing is this is a glow box. Okay. So okay. Actually this is the one kind of preparation technique. So from this one, they are actually preparing the cathode materials. It is in bulk form. So it is like in industry, they are actually preparing the bulk cathode material. Yeah, this is actually the different kind of material to prepare the cylindrical battery also. So they are actually cutting the separator and cathode materials, and finally they are actually preparing the cylindrical form of batteries. Yeah, this is the testing chamber. So finally they can put it for the testing. Yeah, by using this kind of battery, they can use it for different applications like in bikes and cars also they are actually using. Yes, sir. Kanan sir, third one also.
Okay.
Yeah, so this one actually, Kanan sir, big screen, sir.
I couldn't be able to maximize it.
Oh, okay. So this is actually this video shows you how we can prepare the coin cell. I already mentioned there are three types of lithium ion batteries devices. One is coin cell, pouch cell, and prismatic cell, right? So we already seen that one how to prepare the pouch cell. Now we can see that how we can assemble that coin cell. So this is electrolyte. Generally, in laboratory, they can use the lithium fluorophosphate as electrolyte. In chemistry point of view, in chemistry lab, they are actually optimizing the electrolyte also in order to improve the performance of the battery. So now we can see, yeah. So once you prepare the cathode material, right? So we have to optimize the material, and after optimization, we have to coat it on the aluminum foil, and we have to keep it for the assembling of coin cell. So these are all the different accessories of the coin cell. So one is called the cathode cap, now they already placed that cathode cap. So now he is taking that prepared cathode material. So it is on the aluminum foil. Okay, after keeping that one, so they have to drop the electrolyte little bit. Then after they can keep the separator. So this is called separator. It is in white color. It is the separator. The purpose of separator is in order to avoid the short circuit between the cathode and anode. Yeah, finally they can keep the foil, lithium foil. It acts as a anode. So this is a full setup of coin cell. So finally they can keep the one plate. Yeah. Then also they can put the ring also in order to keep it a tight bound of coin cell, because they already filled that liquid electrolytes, right? So it should not come out. So we cannot keep it like this, right? So we have to tight it properly. So by using, this is a hand pressing machine. So by using this machine, they can tight it properly with some pressure. Okay. So this is the method of assembling the coin cell. So Kanan sir, okay sir.
Thank you, sir. I will stop the screen.
Yeah, okay sir. So Kanan sir, is it visible?
Yes, sir. But yeah.
Okay. Okay. Yeah. So I hope you can understand the basic concept of lithium-ion batteries and how we can prepare the cathode materials and how we can optimize the cathode materials, and also how one can assemble the coin cell and the prismatic cell. Okay. So this is the conclusion of the optimization of the cathode materials. So once again, I will tell you. So in cathode materials, we have to optimize the morphology. So the morphology term is very important. Why? Because so optimization of the morphology, which means the surface morphology of the material. So we have to actually optimize the morphology. In which form? It should be in the monodispersed particles. So here you can see that two different picture. In the right side you can see that monodispersed particle. In left side it is called the agglomerated particles, which means in right side it is the particles are arranging in ordered shape. In left side it is in the disordered shape. Simple. Okay. So we have to prepare the material in ordered shape. So that is I mean, in the another form, it is called the monodispersed particles. So the morphology is also very, very important. Why? Because then only the electrons can trap easily in the in the vacuum, in the hollow space. That is the reason. Okay. So if the electrons move very fast, means the conductivity will become high. So the performance of battery will become better. So that is the reason. So we have to optimize the morphology. So it's very, very, very tough. Okay. So by selecting the method, one can optimize the morphology. Okay. Then size and distribution. So what is meant by size? So we can say that grain size or particle size. So we have to optimize the particle size or grain size also. So in nanotechnology, I already shown that slide. So in nanotechnology, we have to, if you bring it the particle size into nano region, then the conductivity will become higher. Why? Because once you once you bring the grain size into nano region, the surface volume ratio will become high. So based on that, the conductivity will become more. So then obviously the energy density will become high. So that is the reason most of the scientists, they are actually working in the nano field in order to bring the materials in the better performance. And also tap density and press density and surface area, impurity, crystallinity. So all the parameters. So we have to optimize all the parameters. Then only we can give the better performance of the battery material. Okay. So this is a cross section of the prepared lithium-ion batteries. How thickness it could be for the cathode side, and how thickness it could be for the anode, and how thickness it could be the separator. So these are all the it gives the idea of the thickness of the different materials. This slide shows you different accessories we have to purchase from the different countries. So we cannot get it from in India. It's very tough. So we have to export from other countries to access all the accessories. For example, lithium foil we have to purchase from China or Japan, and electrolyte from Japan. So like that, anode cap, cathode cap, all kind of accessories we have to buy it from the other countries. So here I would like to show you the few examples, like by using pouch cell or prismatic cells, we can use it in that different vehicles and sports car also. Of course, we cannot expect more speed for patrolling purpose in UK. They are actually using this kind of vehicle by using the lithium-ion batteries. So within the city, they can use it. So with that limited speed. So it's really successive, and they are actually using. This slide shows you the overall view of lithium-ion batteries application. So right from a cell phone to other devices and camera and mobile phone, and even in space also they are actually using the lithium-ion batteries. So now I want to tell you one example, because most of the viewers I already heard from Kannan sir. Most of them are research scholars and faculty members. So I want to tell you one example how the cathode materials is giving the better performance. This is the one example I will show you. This is called lithium iron phosphate. One of my scholar, he already prepared this material. Here he prepared this material in solid state method, and this is XRD. From XRD, the crystallinity has been confirmed, and there is no impurity. And this is the picture of pure lithium iron phosphate. The A1 shows the pure lithium iron phosphate, and to improve the performance of the material, we already coated the carbon. So in previous slide, I already mentioned the importance of carbon, right? So there are different types of carbon materials are available, citric acid, sucrose, adipic acid. So a lot of sources are available. So we can add that carbon source in order to improve the performance of the battery materials. So that we already add that carbon source. So after adding the carbon source, you can see the lot of pores. Okay, so this is very important. Once you create the pores, so the electron mobility will be high, so that the conductivity will become better. And the third picture shows the transmission electron microscope. High resolution transmission electron microscope image, which is called HRTEM, to confirm the carbon coated materials. So here you can see the clear evidence of coating that carbon in the edge side, and this is the lithium iron phosphate. And this is a cycling voltmeter, which is called CV studies of the pure and carbon coated materials. So here you can see that red one, this is carbon coated, and blue one, it is the pure one. So then the oxidation peak and reduction peak you can see. For pure one, it's give the single solder. But after adding the carbon, we can see that there is a double shoulder it gives. So this is the importance of adding the carbon. This is another example, lithium cobalt phosphate. Here also the XRD has been confirmed, so there is no other impurity phase. And this is another method. First one I already shown that only adding carbon. Here the idea is, so we reduce the particle size, so from 5 micron to 100 nanometer. So by using ball milling, so we already reduce the particle size. So here you can see the advantage of reducing the particle size. Okay, so this is a glow box. Okay, she was my MTech student when I was in Amartha Cochin University. So who prepared the coin cell inside the glow box? So this is a glow box. I already mentioned that one. So for making the coin cell or pouch cell, it's not the easy. So it's very tough to prepare because we cannot prepare outside, right? So inside it's very difficult. So this is the comparison table of as prepared and ball milled. I already mentioned, right? So for as prepared sample, the specific capacity it gives 153 milliampere hour per gram. But after milling, by using ball mill, once you mill it, the grain size becoming lower. For the lower grain size, it gives a higher specific capacity, 173 milliampere hour per gram. So this is the most advantage of reducing the grain size. I already mentioned, right? So this is the importance of nanotechnology. So even in batteries also, it already proven. So for a milled sample for lower grain size, you can see the specific capacity is also better, and also stability is also better. So this is the conclusion of that lithium cobalt phosphate. So I already mentioned, I already explained, right? So finally, the lower grain size shows the better performance of the battery material. Okay, so this is a important slide, like the comparison of cathode materials at present, and what are the important materials we can use it in future also. So almost we are in this platform, right? So right now, most of the scientists, they are actually working in that olivine, fluoride, vanadium oxide. So there are different methods. So anyway, it will take another 1 hour to explain all those things. So simply I will tell you that one, like there are many methods are possible. They're actually working in this one, in the cathode side. Of course, in anode side, they're actually selected a tin and graphite carbon based materials. In future, maybe after 10 years or after 15 years, like actually scientists they are planning to changing this kind of olivine material into silicate or sodium. I already mentioned one slide, right? So importance of silicate and sodium sulfur batteries. So okay, the people are thinking to change this material in order to improve the performance. And also in anode side, they are actually thinking to replace that one into carbon nanotubes. So actually one movie is there, but we don't have time now. Otherwise, we can easily understand the importance of carbon nanotubes also. So actually in future, they are actually thinking to replace all those things. And also, these are all the next generation important materials of the batteries. Okay. Now, I just want to go, simply I want to tell you comparison with lithium ion batteries and sodium. Okay, so far we have seen the importance of lithium ion batteries, right? But the point is, the availability of lithium is very low. So we have to purchase it from China, and also it's limited. At present situation, after this corona, we cannot get it from China also, I don't know. So it's really demand of that lithium. So now the people are thinking how one can change that lithium into another material, and of course we have to get that same performance. Okay, so now the scientists are thinking like why don't you replace the lithium into sodium? So because if you see in that periodic table. So the performance of lithium and sodium is also almost equal. So so the people are thinking to prepare the sodium. So this is the present scenario. They are actually preparing the sodium batteries materials. So here I want to show you a few examples. One of my PhD scholar, he prepared a sodium battery also. Of course, the optimization was done and the XRD was clear. And cycling voltmeter also, it gives better voltage compared to lithium ion batteries. So this is a comparison. Just I want to tell you the importance of sodium also. Okay, right. So this is a surface morphology picture of the sodium batteries. So here you can see that. So more the voids, number of voids are there in the sodium. So that here the advantage is the electron can trap easily in this one. So by using the sodium ion batteries also, we can use it for different applications. And so this is recently we published in that one of the reputed journal of Electroanalytical Chemistry. The impact factor is around 3. So it is really good paper, and also it's very tough to publish the work in this journal. So one of my scholar, Richard, he published the paper in this work in this journal. Yeah, finally, I want to conclude this one. So in that vision 2050, of course, I already mentioned there are different sources are possible to get the electricity, right? So from water source and from wind source and the coal source. Okay. So now we are actually thinking to get the source from the device, okay, energy device. Now the idea is, so we have to couple this kind of energy device into solar system, okay. So this is called the hybrid device. Why? Because from solar panel, we can get the energy from sun, okay. So by using that energy storage, we can save the energy by using that energy storage, and after that we can use it. So this is double purpose. So this is called the hybrid device. Now the people are thinking like how to merge the solar cell and the energy storage like lithium ion batteries in one device, which is called the hybrid device. So in future, actually, this hybrid device will come out. So with this, I will stop it here. I hope all of you can understand the concept of lithium ion batteries and how we can prepare the cathode materials, and finally how we can use it for the different applications. So if you need more doubt, you can contact me at any time. This is my mobile number and email ID. And currently, 4 PhD students are working under with me, and I have 2 projects also. So you can, if you have any doubt, you can ask me at any time. So thanks a lot for your kind attention. So thank you, sir. So now it's for time for asking, question.
Thank you.
Sir, few questions are there.
Yes, sure, sir.
One question is, please explain the efficiency of the battery by means of this conductivity of morphological state. Could I repeat?
You mean efficiency of the battery?
By means of conducting morphological study.
Sir, the morphological study means I already mentioned in that few slides. So the morphological study is nothing but the surface morphology. In nanotechnology, once you reduce that particle size, the surface volume ratio will become high. So that will clearly indicate in the surface morphology. So once the surface volume ratio will high, the conductivity will become high. So this is the relation between conductivity and the morphology. So once you reduce the particle size, then obviously the conductivity will become more. So that is the main reason, sir.
So another question is, how the efficiency of the battery maintains the time duration concept?
Sir, efficiency is directly proportional to that time. Okay, so that's why I already mentioned that the comparison of oxide materials and iron based phosphate based materials. So the efficiency will become more with depends on the time. So I already mentioned that graph, right, sir? So that lithium iron phosphate, it always gives the plateau region. So that with the time duration, with that, so the efficiency will become high, where in the case of lithium iron phosphate. But in the case of cobalt phosphate, it won't happen. So that is the main difference, sir.
What is the difference between lithium ion and lithium polymer battery?
Oh, of course. So lithium ion batteries, I already mentioned that typical picture that lithium ions can move from one electrode to another electrode. That is called the lithium ion batteries. Whereas lithium polymer means, sir, I want to forget this point. Like there are two types of batteries are available: liquid state lithium ion battery and solid state lithium ion batteries. So whereas in the solid state lithium ion, the polymer can use it for lithium polymer batteries. So in that they won't insert the liquid electrolyte. They can keep it like polymer. So they want to fill that like a liquid electrolyte. So that is the main difference between lithium ion and lithium polymer, sir. So lithium polymer is the solid lithium ion battery. Lithium ion battery is the liquid lithium ion batteries.
During intercalation, what about the structure of cathode material?
Structure of cathode material, sir?
Yes, sir. During intercalation.
During intercalation, so that the structure of cathode material is the same. For example, once you take the cathode material, for example, lithium iron phosphate is a olivine structure, right? So once you take the olivine structure, during that intercalation, the structure won't change. Unless otherwise, if you give the external pressure or temperature, if you change that one, then there may be chance to change the structure. Otherwise, it won't change that intercalation time. It won't change the structure.
What is meant by dendrite growth? How to avoid it?
Sorry, sir. Sorry.
What is meant by dendrite growth? How to avoid it?
Which growth?
Dendrite. D-E-N-T-R-I-D-E.
Oh, I cannot understand, sir. Dendrite. I didn't mention that one.
Okay, sir. I will go to the next question.
Okay, sir.
சார் ப்ரெசன்டேஷனை கட் பண்ணிட்டு அது வீடியோ ஆன் பண்ணுங்க சார், உங்கள் வீடியோ வந்துடும், நல்லா இருக்கும். ஷேரிங் அந்த க்ளோஸ் பண்ணி
சார் ஸ்டாப் ஷேரிங்.
க்ளோஸ் பண்ணிடுங்க, உங்கள் வீடியோ வந்துடும் நல்லா. கரெக்ட். ஓகே.
ஓகே சார்.
Why CV LFP with carbon coating CV changes drastically?
Cycling voltmeter, sir.
Why is cycling voltmeter LFP with carbon coating CV changes drastically?
So, sir, the point is, after adding that carbon, so what is happening exactly means, it is actually changing the surface morphology so that the conductivity is also changing. Okay, so based on that electron movement, so the cycling voltmeter can display. So the purpose of cycling voltmeter is gives the oxidation reduction peak. So with that, after adding that carbon, the oxidation peak, the shoulder become, splitting into two. So from 1 to 2. So that is the importance, sir.
Another question, in one of your slides, your CV graph, carbonized coated material shows double shoulder. Why?
Yes, sir. Carbon. So the double shoulder indicates the different voltage, splitting of voltage regions. So once you add the carbon, so it shows the splitting, the oxidation splitting. It is called the oxidation splitting, sir.
I think this is the last question, sir.
Okay, sir.
Ball milling will reduce particle size. but the grinding may break the morphology and hence battery performance. Please comment, sir.
Oh, okay, sir. Sir, the purpose of ball milling, so in order to reduce the particle size, of course, that is a really good question. But the point is, once you use that ball milling, the particles should be in the agglomerated. Okay, so of course that is really difficult to optimize these two. For example, once you go for hydrothermal method or other chemical method, we can easily get that monodispersed particle. But in the case of ball milling, so once you reduce the particle size, it could be in a particle could be the agglomerated. But the point is, once you reduce the particle size, the surface volume ratio will become more. That is the main advantage of that one. So because of that, the conductivity will become more. So which means the grain boundary size will be more, so that the electrons can trap easily through that boundary. So that is a more advantage of reducing the particle size.
Thank you, sir. Thank you very much for your nice presentation and explaining the policy. Thank you very much. Screen is up to start.
Sir, na share kodukuma?
Yes, stop.
Na stop panta sir.
Stop. Your screen.
Sir, unga screen vanduchu. Ama.
Dear participants, on behalf of the organizing committee, I should apologize for the inconvenience caused due to the unexpected power supply. I also appreciate the patience shown by the participants. So, for a formal vote of thanks, I should thank our college secretary Arumugam for giving us permission to conduct this webinar. Also, I should thank our college principal, Dr. K.R. Jayakumar, for his support. And my sincere thanks goes to our department staff members, Mr. N.S. Arumugam for his guidance, and also Dr. M.C. Kumar, Ravi Kumar, Dr. S. Marikano, Dr. M. Ramachandran, and Dr. Ramachandran for their unconditional support given to me during this conduction of this webinar.